Inverse of trigonometric functions. So this is the history of inverse of trigonometric functions. Indian astronomers 500 to 900 CE who decided to study what we now call sine and cosine as functions of an angle in a right triangle. After this knowledge was brought to the Arab and Persian world in a medieval times and developed further, it was transmitted to Europe through contacts among merchants and as a result of warfare. The word sinus arose from a misinterpretation of the Arabic word for this concept. Thomas Flink of Flensburg, Germany introduced the names tangent and secant into trigonometry in his book of 1583. Edmund Ganter, between 1624 and 1636, invented cosine and cotangent with the prefix co meaning complement. Daniel Bernoulli, early 1700s, inverse trigonometric function were considered and used as in for the inverse sin of a number and in. Euler 1736 wrote a t for the inverse tangent. G. L. Lagrange, as early as 1772, used the symbols arcsine and arctan. Euler and Lagrange were identifying an angle with the arc it subtends when placed at the center of a circle. John Herschel introduced the sin -1 and tan -1 notations in an article in the Philosophical Transactions of London in 1813. So this is the properties of inverse function. First, a function must be one-to-one in order to have inverse function. Second, the graph of an inverse function is the reflections of the original function about the line y is equals x. Third, if x and y is a point on the graph of the original function, then the quantity of y and x is a point on the graph of the inverse function. Fourth, the domain and range of a function and its inverse are interchanged. Example, y is equals cos x, then the negative of infinity x not one-to-one since some horizontal lines intersect the graph many times. More than one x value is associated with a single value. The inverse relationship is not a function. It will not pass the vertical line test. So this is the vertical line test of first example. A function must be one-to-one in order to have an inverse function. Y is equals cos x, then 0 is less than or equal to x is less than or equal to pi. The restricted cosine function is one-to-one and thus have an inverse function called r cos x or cos to the power of -1x. Second, the graph of an inverse function is the reflection of the original function about the line. Y is equals x. Note, the symmetry of graph of cos x and r cos x about the line y is equals x. So this is the line, vertical line in second example. Third, if the quantity of x and y is a point on the graph of the original function, then the quantity of y and x is a point on the graph of the value inverse function. So this is the quantity of pi over 3, then 1/2 is a point on the graph of y is equals cos x. So cos pi over 3 is equals to 1/2, 1/2. The quantity of 1/2, then pi over 3 is a point on the graph of y is equals r cos x is equals r cos 1/2 is equals to pi over 3. In general, if across x is equals y, then x is equals to cos y The quantity of cos to the power of negative 1, x is equals to y, implies cos y is equals x. Example, evaluate r cos negative square root of 3 over 2 or what angle between 0 and pi has a cosine value of is equals to the quantity square root of 3 over 2. There are infinite number of solutions because cosine is periodic and equals this value twice each and every period. The restricted range of r cos x is 0 is less than or equal to y is less than or equal to pi. Since cosine is a negative for angles in the secant quadrant and reference angle is pi over 6, the final answer is 5 pi over 6. That's all.